So here I'm going to factor quadratics like in the form of ax squared plus bx plus c when a is greater than 1. Remember, when we're talking about a, we're talking about the coefficient of x squared. Of course, in the first example, let's say I have 5x squared plus 20x plus 20. First and foremost, always check if there is a value of a, we check to see if we can factor out a GCF first. So GCF question mark. Well, we have 5, 20, and 20. Do we have a greatest common factor? Yes, we do. So in this case, we're going to start with factoring out the greatest common factor. The only thing all of these have in common, these terms have in common, is 5. So I'm going to factor out 5. When I factor out 5, I'm going to divide each of these by 5. So now 5 divided by 5 is 1x squared plus 20x divided by 5, which is 4x, plus 20 divided by 5, which is 4. Now we have 5 times x squared plus 4x plus 4. Now what I want to take a look at is if I can now factor x squared plus 4x plus 4, which it is factorable. And of course, if you didn't know it was factorable, then you would take a look at the last number. I'm going to use the new method that we're talking about. Draw this little x here. We need the 4, of which we're going to factor. And then, so this is what we need to factor and find the multiples of, and then the 4b here. Now, what are factors of 4? We got 1 and 4, 2 times 2. Which of these would add to get 4? Well, if we do 1 plus 4, we would get 5. So it can't be that one. 2 plus 2 would give us 4, so it's going to be 2 and 2. These factors are now, of course, since you did factor out the greatest common factor here, bring down that 5, set up your 2 sets of binomials, and now you have x here and x here, of course, because x squared is factored, and then the 2, this is a positive 2, this is a positive 2. So these are your 3 factors. 5 times x plus 2 times x plus 2. Moving on. If you have a problem like 6x squared plus 11x plus 3, there's a few more steps, but we're going to be able to factor this one. First and foremost, we need to find out if we have a greatest common factor. Well, 6, 11, and 3. There's no greatest common factor at all, so I'm going to move on to step 2. Step 2 is to do that factor x. Now, in this case, we're going to do it a little differently. We need a times c and then b here. So here, we only needed c and b. So if we go back to the form, a is the first coefficient, b is the second coefficient, c is the constant. So in this problem, the third problem, we need a different method, so we need to multiply a times c. Here, a is 6, c is 3. You always need to pay attention to whether this is positive or negative because you are going to be multiplying that. So 6 times positive 3 is going to give us 18. B is 11. So now, we need to find the factors of 18 that are going to add up to 11. Now, we have 6 and 3. 6 and 3 are 18, factors of 18, but do they add up to 11? To 11, no. 9 and 2. 9 and 2 are factors of 18, and they add up to 11. Yes, they do. Now, here's very important. You put the smallest number on the left, the bigger number on the right. Now, we know that these are going to be in our factors. So, this next step is the third step, which means we have to break down the middle term, so the 11x. To get the 11x, we needed that 2x and 9x. So here we go. We're going to expand the middle. 6x squared plus 2x plus 9x plus 3. This is expanding the middle. We expanded the middle, so now we need to group them. Step 4. So we group them in sets of 2s. 6x squared plus 2x, and then 9x plus 3. So we've grouped them separately, and now we need to see if we can find a greatest common factor of each. Okay, so greatest common factor here, we got 6x squared plus 2x. I can factor out 3. Oh, and I can factor out an x, because we at least have one x in common. So if I divide this by 3x, divide this one by, okay, we can't do 3, so it's 2. So let's divide this one by 2x, divide this one by 2x. Now, 6x squared divided by 2x is going to be 3x, plus 2x divided by 2x is going to be 1. So here we have factored out 2x times 3x plus 1. Next, we need to find out if we have any greatest common factors here. We've got 9x plus 3. We can factor out a 3. We cannot factor out an x because both don't have an x. Now we divide by 3. 9x divided by 3 is 3x. And then 3 divided by 3 is 1, positive 1. Now, you should always get factors that are going to match here. But last but not least, you're going to pull the first factor and first factor here. Those are going to be pulled together. So you got 2x plus 3 times the matching factor, 3x plus 1. These are your factors, okay? That is done, and now we are going to check our work. So one way you can check it is typing in the original trinomial and also the factors into Desmos, and they should cover each other. The second way to do it is to check it with the box method. If I check them from with the box method, I would do the 2x plus 3 across the top, 3x plus 1 down the side. So 3x times 2x would give us 6x squared. 3x times 3 would give us 9x. 1 times 2x would give us 2x, and 1 times 3 would give us 3. If you are able to get the same, this is positive, positive, plus. If you are able to get the same terms that are in that second step, we got 6x squared plus 2x plus 9x plus 3, then yes, you have gotten your factors correct. And that is it.